Well, it might be best to first talk about ordinary insulators. Ordinary insulators are materials that don't conduct electrical currents. And the reason is that you have electrons which are bound to atoms. So it takes some energy to get them off the atoms and liberate them so they can move freely. In a topological insulator, it also takes some energy to move the electrons around, but the important thing isn't they're binding to atoms, it's how they're linked together. So in some sense, a topological insulator can never be related to a state which is just an ordinary insulator. An ordinary insulator is like having a set of isolated atoms. In the topological insulator, it's the links that count. Well, one has a sense that these might be incorporated into very fast, very efficient, small-scale electronics. This is a vision where one would be taking essentially known architectures which we use in our ordinary electronic systems and replacing the active elements by systems that are topological insulators. And I think that is possible, but my own view is the more important payoff is that with a new class of materials, there may be applications down the line which are just sort of impossible using current day quantum materials, but are now enabled by this new class of materials. That would be the more interesting and I think the more impactful application of these systems. So I think there's a kind of physics aesthetic, which is that in science we really appreciate ideas which are universal and essentially simple in concept. And in the area that we tend to work in, there's the possibility of connecting that with things that are actually useful for technology and devices. And I think that's an interesting marriage of the pure scientific aspect based on fundamental and geometrical ideas and the possibility of having real applications involving that.